Good morning, everyone. Previously, I have discussed lab programs 1, 2, and 3, that is Finder's algorithm, candidate elimination algorithm, and decision tree algorithm. In your syllabus, they have it is mentioned that you have to implement all the algorithms without using libraries. Okay, without using inbuilt libraries. Although they have mentioned like that, decision tree algorithm, I have not uh, I have not implemented it without libraries. You can, if you remember, we have made use of inbuilt libraries, Python libraries, to implement that algorithm. Similarly, all other programs, we are not going to implement it from scratch because length of the program will be very big. And as I have seen, most of you will not study that algorithm programs itself if the length is too big. For that reason, all the algorithms will make use of inbuilt libraries and we shall complete the programs. Okay. So decision tree we have done like that itself. Uh, from sklearn package, we had the decision tree library API which we used to implement that program. So similarly, today we shall see lab program number 5. That is the naive-Bayes algorithm. The program is to implement naive-Bayes algorithm and to a particular data set and check the accuracy of the algorithm. Okay. And yeah, in all the lab programs, we'll be using one particular data set, that is iris data set. In the previous, while explaining previous program also, I have shown you this data set. So this is the iris data set. You can see here, this is the iris data set. This data set is about the iris plant. Okay, so that plant can be classified into three classes. Okay, that iris plant can be classified into three classes, and you can see four values. Okay, 5.1, 3.5, 1.4, 0.2. Okay, four attributes are there. Based on these four values, this plant will be classified as iris setosa or iris versicolor or iris virginica. Is it clear? This plant can be classified into three classes based on these four attribute values. So what are these attributes? See, all of you listen carefully. This data set, again, I will not discuss about this data set again in further classes because as I said, we'll be using the same data set. There is no need to discuss about the same thing again and again. So this is a plant data set, as I said. It has got four attributes. Four attributes are nothing but it's a petal length and width, sepal length and width. See, this plant is classified based on its petals and sepals. Okay, what is the length of petal and what is the length width of petal and what is the sepal length and width? These four values represent petal and sepals length and width. Based on these four values, this plant can be classified into three classes: Iris setosa, Iris versicolor, and Iris virginica. Is it clear? So these four values will decide the type of the plant. So we are using this data set in this program. Okay. We are trying to do the training. We are trying to check the accuracy of naive-Bayes algorithm uh, when this data set is provided for the training. Is it clear? So this is the data set. In the ID3 algorithm, decision tree algorithm, uh, we have imported the file. We have given the path of the file, and then we have used that data set in the program. But in this program, directly we are importing the data set from the library. Okay, I will just show you all those things. So if you remember our Spider IDE, we'll be typing program at this place, and output you can see here. Whatever variables we use in the program, that will be visible in this window. Okay, among these three windows, in the first window we'll be typing the program. In the second window here bottom we will see the output. In this window we can see the variables that we have used in the program. So first 3-4 lines or import lines, what are the libraries we are using, we'll import here. And whenever you see sklearn in Python program, sklearn clearly indicates that you are doing something related to machine learning. Okay, in any Python program, if you see sklearn, it clearly indicates that we are doing some machine learning task in the program. So sklearn is a package in Python which has got all the features and functionalities that are needed uh, to implement any machine learning algorithm or any task. So first thing is what you are importing from sklearn.dataset. Import load iris. Okay, load iris. See these spellings. Python is a case-sensitive language. Okay, so spellings are very important. It has to be either capital letters or small letters. If it is in all smalls, you have to type it like this itself. If you make any one single mistake, program will not work. And it will be very difficult to debug if you are making spelling mistakes in the programs. Okay, so make sure you are not making any spelling mistakes when you are doing Python programs. So from sklearn.datasets, sklearn, as I said, sklearn is the package which is related to machine learning. Various datasets are already present in that package itself. Datasets are readily available in this package. So we can directly import the package itself. We need iris dataset. So from sklearn.datasets, import load iris. Okay. So we are importing iris dataset. From sklearn, import metrics. Okay. See that word metrics. When you see that word metrics, metrics means some measuring quantity. Like we want to measure the performance of the algorithm. So we need some metrics. So we are importing metrics again from the sklearn. From sklearn.naive base, see spelling everything underscore sklearn.naive underscore base, you have to type it like this itself. Import Gaussian naive base. In this naive base algorithm, we are using Gaussian normalization. For that reason, its name is Gaussian naive base. You can use other normalization functions when you are using naive base algorithm. In this particular program, we are using Gaussian normalization. So Gaussian NB function we are importing. Again, observe here, G has to be capital letter. Okay, Gaussian naive wave. G is capital and N and B are capital. Remaining things are small letter here. Okay, you need to observe these things. G is capital, all are small letters. Again, N, B are capital. Okay, from sklearn.model underscore selection, import train underscore test underscore split. While explaining decision tree also, I have explained this thing. What does this train underscore test underscore split will do? Again, I will just give you brief information, explanation for that. Train underscore test underscore, see that is very important in machine learning program. Train underscore test underscore split. Uh, our data set, it will split into two parts. This function train underscore test, it will split the data set into two parts, one for training and other for testing. Okay, data itself, it will divide it into two parts, training data and test data. Import numpy as np. Yeah, see, as np is just alias. Wherever you want to use numpy library, you can just type np. Is it clear? So see, if you want to run this entire program together, you can press this green play button. Or if you want to run the program line by line in debugging mode, you can just press this button. Okay. So I will just execute the program line by line. Okay. You can see here, whenever I press that button, that is executed here. Each and every line, you can see here it is getting executed here. Okay, one by one, you just execute them. So I have executed these library instructions. Next thing is iris is equal to load iris, load underscore iris. Okay, so this is the data set which we are using in our program. So we have executed that line. Now iris is a variable which has got that data set. If you want to see that variable, you just type that iris here and you can see that data set here. It has been imported to our program. So this is the data set which has been imported to our program. See, this data set has got, this is the data. Last column is the target, that is y. Data is nothing but x1, x2, x3, x. And these are y values. Y values are the class, iris, setosa, virginica, and versicolor, three classes. Okay, that we call it as target. This is data, this is target. So x is equal to iris dot data. That is sepal and petal length width. That is the data. That I am assigning to x. Y is nothing but the class name of the plant, which is present in iris dot target. So here, if you type x, you can see I have not executed that line, so it is saying x is not defined. Just run those lines and then type x. You can see here, this is the data, only data. Now, if you want to see the y values, it will, again, y I have not executed, just execute it. And then y. Okay, it's a small y. See, observe carefully, capital X, small y I have used. Okay, 0, 1, 2. 0 is the class. So class name either 0 or 1 or 2. Is it clear? That is the class of the plant. Next thing is our data is there in x and y. That data I have to divide. See, this is the data. This is x and this is y. This data I have to divide it into training data and test data. In machine learning, this is the first thing we do. So I will just execute this line. Okay, that line is executed. So this train underscore test underscore split of xy, x and y values you have provided, you must provide as arguments. It will split this data into training data and test data. So it returns four variables: x underscore train and x underscore test, y underscore train and y underscore test. X underscore train and y underscore train is training data. X underscore test and y underscore test is testing data. See, why we have to divide the data into two parts. First thing is training data is used to build the model, machine learning model. Using algorithms, we'll train the system and we'll prepare the model. So once model is prepared, we need test data. We need test data to test the accuracy of the model. Okay, I need to find out how training has been done. For that reason, whatever data we have, that data we have to divide it into training data and test data. Okay, our data, whatever we have, that data we'll split it into training data and test data. It returns four variables: x underscore train and y underscore train, x underscore test and y underscore test. Then we need to call this the Gaussian Naive function. Okay, GNB. I am calling that function. So see, here we have just split the data. Next thing is we have to do the training. As I said, to do the training, we need x underscore train, comma y underscore train. So GNB dot fit. Dot fit means we are doing the training. Okay, using naive Bayes algorithm, we are doing the training. Once you do the training, that model will be ready. Okay, training we are doing with the help of the training data, that is x underscore train and y underscore train. Now training is over. Next thing is we need to do the prediction. Prediction is nothing but testing. Okay, how well we have trained the data. For that, okay, GNB is our Gaussian Naive function. GNB dot predict. What we have to predict? We have to predict the text data. Okay, x underscore test. What is that prediction we are going to get? So it will return y underscore predict. Okay, so first See, in machine learning programs, first thing is split the data into training data and test data, split it, and then do the training. To do the training, we'll do dot fit x underscore train and y underscore train. Once training is over, you need to do the prediction. Dot predict the text data. Okay, x underscore test. Once you predict it, you'll get the result y underscore predict. To check the accuracy, actual result is present in y underscore text. Predicted result is present in y underscore predict. Okay, actual result y underscore text. Predicted result is present in y underscore predict. If you compare them, you'll get the accuracy of the algorithm. Okay, matrix dot accuracy underscore score y underscore test comma y underscore predict. So if you run this one, you'll get the accuracy of the algorithm. So you can see here Gaussian Navier model accuracy is 95%. Is it clear? See, uh, our actual result is present in y underscore test. Predicted result is present in y underscore predict. So if you execute, if you want to find out the accuracy, metrics from sklearn we have imported metrics dot accuracy underscore score. Between these two things, if you check, multiply by 100, you will get the accuracy of the algorithm. Accuracy of this algorithm is 95%. So till now, up to this part of the program, what we have done is we had the data using which we have trained the model, and with the same data we have tested it. Okay, the data we have divided into training data and test data, and then we have tested that data against the trained model to find out the accuracy of the system. Next thing is what we can do is that was the known data. Now you can give new data and check how does our model performs. Okay, so this is new data, 4 values. You just give 4 values. That is, assume that this is the petal length and width, sepal length and width. These 4 values you just give, any 4 values you give, and try to find out which plant it is. Okay, 4 new value I have given, which I will assign to x underscore new. Okay, array values. 4 array values I am taking. Okay, I'm just displaying those 4 values here. Okay, these are 4 new values. Now I want to find out what my algorithm will classify in this new data as. Okay, gnb dot predict x underscore new. So these 4 new values I want to predict to which class this plant belongs to. Okay, here you can see it has predicted the target value as class 2. So class 2 means in the target names I want to find out the name. Okay, predicted feature name is Virginica. Is it clear? For these 4 new values, 4 new petal length and width, sepal length and width, I was trying to find out to which class that plant belongs to. So it is saying Virginica. You can again change the values, give some values, and check now to which class this plant belongs to. Okay, now it is saying versicolor. Okay, so that for this petal length and width, the plant name it is predicting as versicolor. Is it clear how you need to execute the program? See, this is line by line I have executed. If you don't want to execute it line by line, just press this button. It has executed all the program together. Okay, change these values and then just run the program directly like this. So it has executed and it is giving you the result. So it's a simple program. Okay, basically it's a simple program, and you need not have to implement these programs from the scratch. In industry, no one will expect you to do the hardcore implementation. Already those libraries are present. These libraries are present in sklearn. You can make use of those libraries and do the coding very easily. Is it clear? Simple libraries algorithm, which is used to which we have implemented using sklearn library. against iris dataset. So this program will check the accuracy of the naive Bayes algorithm, as well as if you give four new values as input, it will predict to which class that plant belongs to. Okay, among the three given classes, to which class that plant belongs to. Okay, this is naive Bayes algorithm. Uh, in the Google Classroom, I will be uploading these programs. If data set is needed, I will upload the data set. Otherwise, I will just upload the program. All of you try to execute these programs and upload the screenshot. Is it clear? Uh, Yesterday, I asked CR that lab internals has to be done, and principal is asking. Principal has informed that